Hello, today we are solving the 8th question in the LeetCode Advanced SQL 50 list. This is top travelers. They give us two tables of input. The first table is called users and it looks like this. We have just a list of users. The first one is Alice, second user is Bob, etc. Then the second table is a list of rides, for like car rides. We have the ID of the ride, the ID of the person who took the ride, and how far that ride was. For example, the first ride was taken by user 1, which we see here as Alice, and Alice's ride was 120 kilometers long. They want us to find how far each user traveled. Let's use Alice as an example. Did Alice take any rides? Yes, she is user 1, and we can see user 1 took a ride here, and it was 120 kilometers. So we will return Alice along with how far her car ride was. Now let's look at another example. Elvis has an ID of 19. We can see he took 2 rides here and here. We want to add up how long his rides were. So this one was 50 kilometers and this one was 400 kilometers. So in total, Elvis traveled 450 kilometers. And we will return Elvis along with how far he traveled, 450. Then we will repeat for every single person in this table. We have Bob, Alex, Donald, Lee, Jonathan, etc. Then after getting it for every person, they tell us that we want to order our results based on the travel distance in descending order. Meaning we want who traveled the most at the top, and then as we go down, we have a smaller travel distance. So we would want to put Elvis above Alice, right? Because Elvis traveled more than Alice. In fact, our desired output would look like this. And we have how far each user traveled, and the travel distance goes from highest to lowest. There's a small edge case. They also mention that if 2 users traveled the same distance, order them by name in ascending order, meaning in the case where we have 2 people who traveled the same distance, for example, Elvis and Lee both traveled 450, we want to order it in alphabetical order. So Elvis above Lee. That's it. That's all we need. How do we go about solving this? Always as a first step, let's see what data we need, right? Do we need to use both of these tables? Well, this rides table has how far each person traveled. So we're going to need to use this to get the total of each person's travel distance. Do we need this table? They want us to return the name of the person, right? We need to use this users table because this table actually has the names of the people, right? So we're going to need to use both of these tables together to get the name from this table and the travel distance from here. Therefore, we're going to need to perform a join and join these 2 tables together. How can we join them? Both tables have a user ID, right? We have the ID of each user here. And then in this table, we have the ID of each user who took a ride. Therefore, we can join these 2 tables on these 2 columns. What else do we need to do? Well, the travel distance, how did we get that? For Elvis, user ID 19, we saw he had 2 rides. One was 50, one was 400. We summed them up together. We added up all the distances for Elvis, and that is how we got the travel distance. So we will need to perform a sum aggregate function. We want to sum the distance in this rides table. Now, if we just say sum distance, we're just going to add up all this together and get one result, right? We don't want that. We want the sum per user. We want the sum everywhere. It's Elvis, user ID 19. Then we want to find Lee, all of his rides, user ID of 7, and add those up. So we want to sum the distance grouped by the user ID. Therefore, we're going to specify that we're finding the sum of the distance for each user. Now remember, we want to order our results, right? Highest travel distance at the top, all the way down to the lowest. So we are going to want to order the table by this, right? We sum all the distances, this column, and then we order it by the total distance traveled from highest to lowest. So we will order by the sum of distance again in descending order from highest to lowest. Even after we ordered by travel distance, Elvis and Lee are still tied. How do we want to order now? By the name, ascending order, alphabetical, A to Z. Now, is this it? Are we done? We joined the tables together, summed up all the distances, and then ordered it just like they wanted us. There are a few edge cases we need to take care of. Let's try running this in code and see what we get to see what we need to fix. So our first step was to join our 2 tables together. All right, let's join. We're going to select all of our columns from now. Our first table was called users, and our second table was a list of rides. How did we join them? Remember, we combined them wherever the user ID here was equal to the user ID here. So we're going to join on these 2 columns. The user ID in the users table is equal to the user ID in the rides table. Let's see what this gives us. Ignore all the red and white coloring. Here we have our 2 columns from the users table, the ID of the user and the name of the user. All right, we got that from here. 1 Alice, 2 Bob, etc. And then we have our 3 columns from the rides table: the ID of the ride, the ID of the user who took the ride, and how far that ride was. And so we combined our information wherever this was equal to this. Now in one table, we know that Alice traveled 120 kilometers. Alex traveled 222. We have both the name and how far they traveled in one table now. We want to return a person's name and their total distance traveled. So let's do that. All right, perfect. We're getting there. We have the name of the person and how long their ride was. Our second step will be to sum the travel distance for each user. So we want to take wherever Elvis appears, right, twice here, and sum these distances up. We're going to sum the distance, and we want the distance per user. We want to group this sum by the user. However, we cannot use name to group by. Why? Well, because we could have 2 different people named Alice, right? User 1 might be Alice Smith or whatever, and user 17 might be Alice Jones. They're both going to have the same name, and if we group by the name, we're going to add up all their distances together, which we don't want. Therefore, we want to group by the actual ID of the user, right? Because this ID column uniquely identifies each person, so we want to group by this users.id column. All right, here we are. This is what we have: the name and their total distance traveled. They want us to call this sum column travel distance, so we're going to rename this to travel distance. And now all that's left is to order from the highest travel distance to the lowest. So we're going to order by this travel distance, the highest to the top, so travel distance. And like they said, in the case of a tie, if they both traveled the same distance, order them alphabetically by name. So we want Elvis above Lee. Order by the name in ascending order. And here we go. Are we done? Well, if you've been paying attention, you may have noticed that we are missing an entire person. Our expected output has Donald here, but we completely erased Donald from our output. Why is that the case? Why does Donald not show up in our result? When we joined our tables together, when we joined this to this, we combined them wherever the user IDs matched, right? We saw user ID of 1 Alice. Did user ID 1 ever take a ride? Yes. Over here, Alice took a ride and it was 120. So we combine this into one row in our join table. However, for Donald, who has a user ID of 4, he never took a ride. His user ID does not show up here, so he never traveled. Because we used a regular inner join in our code, it will only combine rows if they exist in both tables. So Donald with ID of 4, his ID is not here, so we are just erasing Donald from our output. We are going to have to use a left join, meaning we will keep everything from our left table, the users table, even if it doesn't exist in the rides table. So we will see, hey, does Donald appear in our rides table? No. Just fill it with blank information because Donald never took a ride. So we want to still include him, but fill it with blank information. So let's try it. Instead of a regular join, let's use a left join. There we go. Perfect. We got Donald. However, his travel distance is null, right? Donald never took a ride. So by using a left join, we just said, hey, fill all of his ride data with null because we don't know what to put in. Now, how do we handle this? This is one of those things about SQL, either you know or you don't. SQL has an if null keyword, which takes 2 arguments and says, hey, if A is null, return B. But if A is not null, just return A. So in this case, we can use it to check, hey, if the sum distance traveled is null, like in the case of Donald, we want to return 0 instead. If it's not null, if it's like everyone else, Elvis and whoever, then just return some distance. Nothing changes. But on the off chance it's null, return 0. So let's try here. If our sum of distance is null, return 0. Otherwise, everything else is the same. Does this run? Perfect. It's accepted, and our output, we can see ordered, and Donald has a travel distance of 0. Let's submit. Awesome. Our solution works. Anyways, let's just go over all the steps we took. We first joined our tables together. And remember, we used a left join because we wanted to include people who never took a ride. Then we summed up all the distances per user, grouped it by the user ID. After that, we ordered it just like they wanted to, travel distance from highest to lowest. And then if it was still a tie, order it by name. And lastly, we handled the edge case where if the distance is null, in the case of somebody who never took a ride, just replace it with 0. And that's everything. Thank you for watching.